In today's lesson, which is lesson P.1, we are going to be able to assess the truth of mathematical statements, understand absolute value, evaluate expressions, and simplify expressions. So, leading off, to be able to first assess the truth of mathematical expressions, we're going to have to be able to first answer the question, which is larger between two numbers? So we're going to be answering questions like the ones on this page here. But in order to do that, we first have to answer the question, which is bigger or which is larger? So when we mean larger, what we mean is more to the right on a number line. That's what we mean when we think of which is larger. Well, if you envisioned a number line, which of these two would be more to the right? Well, it'd be the 2. So another way we could write this would be -6 is less than 2. So that would be an example of a true statement that we could write from those two numbers. So I just want you to go through and circle the rest of these. Which one will be more to the right on the number line? So -7 would be to the left of 4, so 4 is bigger. -3 versus -12. -12 would be more to the left, so -3 is bigger, it's more to the right. And then +4 is more to the right compared to -2. All right, let's use this information to help us answer these questions. All right, first, to be able to read these, is each statement true or is it false? Well, first we have to be able to read these. And we always read them left to right. Left to right. And so the way we say this is by saying -4 is less than or equal to -6. Now, that's how we would read this. Again, left to right. And the way we indicate the larger number is by which direction this mouth, so to speak, is opening. So since opening to the right, we think this is the larger one. So that's why this is read -4 is less than or equal to -6. Whereas this would be the opposite. It'd be -4 is greater than or equal to -6. So we can identify these based on, is this eating the right one? So -6 is actually less than -4. So this is a false statement. False statement. Now, which is greater, 4 or -2? Well, 4 is the greater one. And is this a true statement then? 4 is greater than -2? Yes, that is a true statement. -4 is greater than or equal to -6. That's also true. And then 4 is less than 6. If you're ever confused, just think about, okay, circle the one that the mouth is eating, and then decide, is that one actually greater? Is that more to the right on the number line? And yes, if that's the case, then it is a true statement. Okay, so rewrite without absolute value signs. Basically, another way to say this would be simplify. But before we do this, let's first explore now what so what does absolute value, what does it mean? What does the absolute value signs mean? Well, absolute value, its definition is distance from 0. Distance from 0 on a number line. So when we evaluate absolute value, we ask ourselves, what is this value's distance from 0? Well, if we're taking the absolute value of 4, if we were to visualize this on a number line, and there's 0 and here's 4, 2, 3, and 1. we can see that the distance away from 0 of 4 is 4. And then the same thing goes for negative 4. If we plotted it to negative 4. Negative 4 is also 4 units away from 0. So the absolute value of negative 4 would be also be 4. So you may remember that one of the reasons why you may remember the rule that absolute value takes positive numbers and keeps them positive, or makes negative numbers and makes them positive. Well, the reason why that is because a distance is always positive. So that's why it makes positive numbers and keeps them positive, takes negative numbers, makes them positive. All right, let's practice a little more here. So rewrite without, so we're simplifying. So absolute value of 0. Well, the distance from 0 to 0 is 0. Okay, I've got some absolute value in here. So I've got the absolute value of 3 minus 7. But again, I perform this operation prior to actually assessing the absolute value. So I do 3 minus 7 first, that's negative 4. Then I take the absolute value of that, and I get 4. Okay, 3 minus 7. Again, that's the same thing as what we had over here. So negative 4, which is 4. Okay, some different variants of the same kind of concepts. Again, you're kind of following order of operations in a sense. So when you have absolute value with operators within them, so like we have this negative 4 plus the absolute value of negative 7. Well, first, that's going to be negative 4 plus absolute value of negative 7 is positive 7. And now I would perform this operation before taking into account that this is absolute value on the outside. So just negative 4 plus 7, that would be 3. Absolute value of 3 is 3. Okay, so again, I've got operators inside of an absolute value. First, I'm going to evaluate negative 3 minus negative 7, which is going to turn to negative 3 plus 7, which is 4. Then I account for the fact that there's absolute value. Absolute value of 4 is 4. Okay, negative 7 divided by the absolute value of negative 7 would be negative 7 divided by positive 7, which is the absolute value of negative 7. Divide those, negative 1. Again, we're just treating absolute value like any other operator, kind of treating it like parentheses in a sense. Okay, now let's think about how we could do something like this. So we're going to express the distance between the given numbers using absolute value and then evaluate the expression. Okay, express the distance between the two numbers, between the given numbers using absolute value. Well, distance between numbers, let's think about this for a moment. If we have two numbers on a number line, we'll call them 2 and 17. What could we do? What operation can we perform that gives us the distance between those? Think to yourself. You might be thinking, oh, the distance is 15. Well, if you're thinking that and you already know it, think about how you came up with that. And the way that we came up with it is by subtracting. Now, 17 minus 2, that is 15. But that doesn't use absolute value. Absolute value, we just take the absolute value of the difference. But the nice part about absolute value is you don't have to subtract them in any particular order. Both 17 minus 2 or 2 minus 17 both have an absolute value of 15, which is the distance between them. So that's how we use absolute value to express the distance between two numbers. Either one of those two, which both lead to 15. All right? Negative 6 and 8, again, same thing. You can either do negative 6 minus 8, absolute value of which is 14, or eight minus negative 6, absolute value of which is still 14. So it doesn't matter which way you do it as long as you subtract them and do the absolute value of that difference. Doesn't matter in which order you subtract them. All right, moving on to evaluating expressions. So if we're evaluating expressions, essentially we have an algebraic expression, and we simply substitute in for the known values of x and y. So we're substituting in. So I'm going to substitute in the 4 for the y and the negative 2 for the x, and then just simplify. So I've got 4 minus negative 2, absolute value. 4 minus negative 2, that's 4 plus 2. So absolute value of 6, which is 6. And that's as simple as that. All right, more complicated examples. Again, we're substituting in negative 2 for all my x's and positive 4 for any y's. Just substitution. So I've got the absolute value of negative 2 all over 4 minus the negation of negative 2 all over the absolute value of negative 4. Okay, just working through here, simplifying. Got 2 over 4 minus 2 over 4. Well, any number minus itself is going to be 0, but you could also say 2 minus 2 over 4 is 0 over 4, which is 0. So 0 would be the answer for this one. All right. Again, more of the same. This is actually the Fahrenheit to Celsius conversion. C equals 5/9 times F minus 32. But again, we're evaluating for a Fahrenheit temperature of 77 degrees. So 5/9 times 77 minus 32. Again, following the order of operations. 5/9 times 77 minus 32. Well, 77 minus 2 would be 75, minus 30 gives us to 45. And then I can simply multiply. And without a calculator, I can reduce. So I've got 5 times 45 over 9. And 45 over 9, that can reduce. 45 divided by 9 is 5. So 5 times 5, that is 25, would be our answer for this one. Okay, got a couple more slides. You might recognize this as the quadratic formula. So sometimes there are more complicated formulas that we should evaluate. So again, we're practicing. So I've got b for negative 20. So I've got negative 20 plus the square root of negative 20 squared minus 4 times a, which is 4, times c, which is 25, all over 2 times 4. And again, I'm just going to simplify this following the order of operations. Remember, order of operations is PEMDAS. Be happy to help you more specifically with this if you need help with this. So I've got 20 plus the square root. Negative 20 squared is positive 400 minus 4 times 4 times 25. A little mental math trick. I'm going to do 4 times 25, which is 100, times another 4, which is 400. So it's 400 minus 400 all over 8. That's 2 times 4. That's just going to be 0. So our only answer here is 20 over 8, which we can simplify dividing both by 4 to get 5 over 2 as our only answer for this All right, again, simplifying. So for this one, it looks like when we're simplifying, we're just trying to distribute and combine like terms. So the distribute step is where we multiply the coefficients of these expressions into each binomial. So we have 7 times 3y, that's 21y, and 7 times negative 5, which is minus 35. So we have that. Then I've got 2 times 4y, that's 8y, and 2 times 3, which is 6. And now I can just combine like terms. And remember, I identify which terms are like each other by noticing which ones have variables. And the ones that have the same variables I can combine. So 21y plus 8y would be 29y. And then negative 35 plus 6, that's negative, this is positive, so it's minus 29. You might be tempted, perhaps, to factor that, but again, it just has to simplify. We do not have to factor. We'll get into that at a later date. All right, lastly, we have this final simplification problem. So notice how we have multiple layers of parentheses, and this is technically a bracket here, but they act all the same. They act like parentheses. So we want to start by distributing completely within the inside. So we have 7 minus 4 times 3 minus, and you can think of this like a minus 1, where you distribute that negative 1 in both terms of that binomial. So it's minus 4y, negative 1 times 4y is negative 4y, and negative 1 times negative 5 would be positive 5. I could combine like terms in here. Positive 3 and positive 5 make 8. So 8 minus 4y. I still have 7 minus 4 out here. Now, some of you might be thinking, the 7 minus 4, that's dying to become 3. But again, that doesn't follow the order of operations. We first must multiply this 4 into this 8 minus 4y prior to combining it with that subtraction there. So we're going to multiply this 4 into the 8 and the minus 4y. So we've got 7 minus, so negative 4 times 8 is negative 32. And negative 4 times negative 4y would be plus positive 16y. And then I finally just combine like terms. The only terms that are like now are this positive 7, this negative 32. So we combine them to get negative 25. So negative 25 plus 16y. And that concludes our lesson on lesson P.1.